Hello everyone, and welcome back to the last video here in this video review series for chi-square testing. Now, the chi-square test we're going to talk about today is essentially the same exact thing as a test of independence. The mechanics are the same, the formulas are the same, the degrees of freedom are the same, everything is the same. The only difference is what type of question are you being asked? And so what we're going to talk about today is the chi-square test for homogeneity of proportions. So let's jump right into it here. How do we know what type of chi-square test we're using? The difference between a test of independence and a test of homogeneity is that now you're going to be given two populations, but only one type of category. So as opposed to a test of independence where we had one sample and we split them, this is going to be two completely independent populations, or more, I should say 2+ populations, and we're going to categorize those populations under one umbrella. So essentially it's something like, are the same proportion of people from Connecticut and New York Yankees fans? As opposed to taking one sample of people from Connecticut, splitting them up then by county and by baseball team. Right, so we're going to see 2+ independent populations, and do we have the same proportion of people in the same category? Right, and so how is it different from other chi-square tests? What we're looking for is the same proportion in the same category, which, mind you, that's also a test of independence, right? Like that is the idea. However, this right here is the difference, is that instead of looking at one population and two events, we're looking at two populations and one event. So how do I calculate my expected counts? It's the same as an independence test. And if you forgot that, it's your row total times your column total over the total sample size. Right? That formula stays the same. Now, if we take a look at an example question here, right, this is what I'm talking about, where this is an example of a chi-square test of homogeneity. Right? We have three separate cities, Baltimore, Detroit, San Diego. I can only be from one of those places, right? And it's the idea of whether or not these teenagers have consumed a soft drink in the past week. So that is my category. Did you have a soda? Yes or no? And then I categorize them by the city they're in, and we're looking for, are the same proportion of kids in each city having soft drinks. And so we level the playing field by looking at proportions, right? And we can actually do this test here. And so for this particular one, I have to find a decent calculator. Here we go. Got it. And so if I input my numbers here, I have to actually enter some names here. So here we go. We got Baltimore, we got Detroit, and we got San Diego. And then on here, I've got yes and no. And now I can input some numbers. Here we go. So 727, 1232, 1482. My no's were 177, 431, and 798. The significance level, I'm cool. We're just going to pick 0.05. And now for this particular one, here's what's crazy. All right, if we do this whole thing out, you get a chi-square value here of 86.49. My degrees of freedom is rows minus 1 times columns minus 1. So that's just 2 degrees of freedom. But essentially here we get a p-value of 0, which probably isn't so surprising when you look at the proportions here. We're looking at roughly 77% of kids in Baltimore having a soft drink, a little bit closer to 75% in Detroit, but then in San Diego, it only ends up being about 2/3. And so, yeah, those proportions are quite different when we're looking at the scale of 2,000 or 2,300 people in a sample. So here, we would absolutely reject our null hypothesis, and we do have evidence of different proportions amongst the cities. Or in reality, if I phrase it the way that AP wants you to, we have evidence that at least one city has a different consumption rate of soft drinks among teens. So, I hope that was helpful, and I'll see you guys in the videos about t-tests. Bye.